Okay, we're in section 28. This is the material on the word problems here, and they're like min-max problems. So we'll go through each example for the homework. The intent is over here, if you've listened to lecture, you studied the material, studied the examples we've given you, that this homework should be rather easy for you. Yes, in the blue area, there's answers for you with work. The work that I do with the board might look a little different than the work that we're doing here. Sometimes when you read something, you might let the variable be something different than what I have in my notes over here. But the intent of it is the answers will be the same, all right? So we'll go through these problems over here at the whiteboard. You need to do these on your own, though. It isn't like you watch someone do these and say, that looks good to me. You need to do them. And what does that mean? That you need to put the effort in, and the effort is substantial for a lot of students. For one thing, they're trying to shore up some deficiencies in the past to allow them to move forward. They got to rebuild their foundation, so to speak. So I'm going to go over the problems. I'll go to the whiteboard. And as I do that, I do want to recommend that if you do have substantial problems that need to be addressed that go beyond what we're offering you, that a good thing to do is come by during office hours where we can have an honest conversation about what needs to be done. Okay, so let me switch the board to the whiteboard. And we'll start. Okay, we're at the homework, and we'll look at problem number one. And by that, what I mean is, certainly read it. It says, a wire of length 40 meters. So I'm going to, draw my rough picture of what a 40-meter wire would look like, something like this over here. So this is 40 meters long from end to end. All right, it says it's divided into two pieces. So I'm going to cut it. And, since we're going to cut it, I don't know where to cut it, but I have to cut the wire into two pieces. All right, so this is 40, by the way. I'm going to cut it here. All right, so I'm going to say this piece here is X, and this piece over here is going to be 40 minus X. So I cut the wire. So a wire of length 40 meters is divided into two pieces. I just cut it. All right. One of the pieces is going to be bent into a square. So I'm going to take this piece here and I'm going to bend it into a square. Now, I'm not saying it's the best looking square, but it's my square. So then the question becomes is, if that's bent into a square, the length of each side has to be the same. So the length of this side over here is going to be 40 minus X divided by 4. All right, let's keep going. All right, so I'm just reading and I'm showing what I've read. So the other thing is, the other one's bent into a circle. Well, this is more difficult, but if I bend this into a circle, it will look like this. All right, again, I'm not saying it's the best looking circle. So the only thing I know about that circle is the circle's circumference is X. All right, so the circle circumference X. So someone says, what's the circumference of a circle? It's really, well, it's 2 pi r, right? So I'll write that over there. So this is really 2 pi r. Okay. So I'm going to keep going, and I want to keep reading and see what they're going to do with this. How many meters of wire should be allowed to the circle? Well, that was fortunate because that's what I want to know. How many meters have been allowed to the circle? I don't know. It could be 1 meter, 2 meters. Well, let me put this down for you. The X could be what? The X has to be between, if I'm cutting the wire, 0 and 40. It has to be if I'm going to give it to the circle. So how many meters of the wire should be allotted to the circle so that the sum of the areas, now they talk about this, the sum of the areas. Let's write this down. Well, what's the area of the square? Well, the area of the square, this is the area of the square, is going to be 40 minus X over 4 squared. I'll put that down now. And what's the area of the circle? Well, I got to figure that out. The area of the circle is going to be, let's see, area of the circle is going to be pi. Well, I need to know the r, right? So it's r squared. But remember, we need to know what this is in terms of x's. So what's r? Well, I'm going to look at this. R is going to be x over 2 pi. Well, that's pretty simple. Let's write that down. So we get pi times x over 2 pi squared equals f of x. All right, I got to go back and read it because I don't know what they're going to do, but they did say to some of the areas. So how many meters of wire should be allowed to the circle? I don't know that answer. It's X in my picture. To the circle, so the sum of the areas minimized. So what I have to do, I have to minimize this. How do I do that? Well, I know the X has got to be between 0 and 40. So I'm gonna do my derivative. And that should be fairly easy to do. I'm going to put it down for you. It's going to be 2, 40 minus x over 4 to the first power times, do it for the inside, I'm going to be careful here, right? Minus 1/4. Let's see, plus, I got to keep going, right? So it's going to be 2 pi x over 2 pi to the first power. And the derivative of the inside is going to be what? Well, it's going to be 1 over 2 pi. All right. By the way, I don't like using the 1 there, so I'm gonna erase that. So some people, they look at it and say, is that a derivative? That's my number 1 there. So I'm gonna erase this. All right. I'm gonna erase this one over here too. Now, what I want to do is derivative is defined everywhere. It's certainly defined in the domain of that, but it's defined everywhere. I'm looking, do we want it to equal to 0? So I got some work to do now. So I'm going to say, when is f prime equal to 0? Well, let me see if I can simplify this. And I'm looking at this, it's 4 times 4 is 16, and then times 2 would be an 8 over here. And then what do I get? I would get minus 1 times that, which would be x minus 40. Again, we have an answer key to look at, and we will look at that later. Right now, what do I get? I get plus, well, 2 pi would cancel off. I'd get x over 2 pi. Again, I'm not beyond making mistakes. Now, what am I going to do? I'm going to try to solve it for x. And let me see if I can do that. I'm going to write, and again, the way I do algebra, you do algebra might look a little different, but it shouldn't be substantially different. So I'm going to multiply both sides by 8 pi. You get 0, you get pi, x minus 40, plus 4x, I think 4x, right? Yeah, pi's cancel. Yeah, 4x, not bad. 0 equals pi x minus 40 pi plus 4x. Let's see, I'll add the pi's, the x's together. So you get 4 plus pi times x minus 40 pi. Again, I'm still trying to solve for x here. And again, we'll look at the key later. So 40 pi, and then divide by 4 plus pi would give me x. All right. So I'm going to analyze, and I know it's tough. I'm not saying it's easy for students to do this, but this is going to be 0. This is going to be 40. I'm analyzing the derivative, and 40 pi, I'm just going to look at, I do some really kind of basic arithmetic. So I'm going to say the top's about 120, and the bottom is, 4 plus 3, about 7, and 7 into 120. Well, let me just, ballparking it, right? 7 into 120, 1, 7. You get the idea what I'm doing, at least at the 3, 5. Let's see, about 17. So I'm going to say maybe over here somewhere. All right. Let me erase my baby arithmetic. I'm just getting a feel for it. I'm going to erase this business over here. Sorry about that. And let's take a test point. All right. So this is a lot of work to do this. And for some students, it is a lot of work. All right. Oh, by the way, this number here is 40 pi over 4 plus pi. What's a good number over here? I would say 1's a good number to choose. And someone says, where do you plug that in? Into the derivative, right? Into the derivative, right? This is derivative over here. Now, if you put a 1 there, what would you get? I'm kind of looking at it, and I think I want to simplify the derivative for you a little bit, not too much. And what are you going to get? 40. Oh, you know what? I guess I did simplify it. Let me put that down for you. I'll write it over here. Just give me 1 second to back up a little bit. And again, your skills in algebra is really kind of necessary for you to do this. I've already done the work, so it's going to be x minus 40 over 8 plus x over 2 pi. Now, if I plug in 1 there, what would I get? Well, I get minus 40 over 8 plus, it's going to be definitely a negative number. Decreasing. Now, what's a good number to choose over here? I would say, maybe like 39. If I plugged it in, what would I get? I would get minus 1/8. Right, that's not so bad. The first term. The second term would be, oh, that much greater, so it's positive. What am I seeing? I'm seeing a minimum. So what's x going to be equal to? I have to allot the wire 40 pi over 4 plus pi to minimize that function. I'm going to claim you go to the answer key now and look at it and make sure they're answering it the way you answered it. Let's take a look at it. It does say 40 pi over 4 plus pi. I do see that. And right over there, it says that's what we need to allot. So I'm feeling pretty good about it. If you look at the work, really the same work, all right? Let's look at the next problem, number 2. And again, it's reading, understanding what you've read, sort of like writing down what they said about it, and then see if you can use your calculus to answer the question. Where they say find a positive number x. Now, what do I know reading it? I know x is positive. That's all I know about it. It's above 0. And it says that the sum of 25x, so they say the sum of 25x and 1 over x is as small as possible. So it's a minimization problem. What are we trying to minimize this? Let's see if we can do that. Now, the domain of this thing over here is this over here. So that's my analysis going to go on that domain. So let's write the derivative down, f prime. That's going to be 25 minus 1 over x squared. All right. Now, certainly I'm looking at the domain of that, and that's defined on its domain, that derivative. What am I looking for? When is it equal to 0? And I'll write that down for you. So 25 would equal 1 over x squared. That would make f prime equal to 0. And what do you get there? Well, let's write this down. Let's see, x squared would equal 1 over 25. So x would equal plus or minus 1/5. But here's the deal. It can't be minus 1/5. So there's only one critical number, and that critical number is going to be x equals 1/5. Well, let me put the analysis down. It starts at 0, and it goes off to infinity. And we got one test point, which is 1/5. And this is the derivative. You're going to plug a number in. I'd say a safe number over here would be 1. If you plug in 1, what do you get? 25 minus 1, which is a positive number. That means the function's increasing. If you took a number below 1/5, like 1/10, and plugged it in, you're going to get a negative number, which means it's decreasing. What is this doing? Minimization. So when does a minimization occur? At 1/5. So what did I find the positive number? Yes, the positive number is 1/5. Let's go to the next page, see if it's answered. And they say 1/5, and that's a good deal. All right, number 3, they give me a picture, and it says, find the rectangle of maximum area. Let me point out what I mean by that. This is the rectangle I'm looking at. They gave me a picture. I see the rectangle clearly. Thank God for the picture, by the way. And they want to find a rectangle of maximal area. All right, so I'm trying to maximize that area. I can read that again and again and again, but it says find the rectangle of maximum area that's inscribed. That means it fits inside that. And they just give me a representation. It's not telling you what it is. They're just saying it's a representation of what it is. It says, this has 5 and 8. I see that in the picture. And I'm going to, maybe put down, I don't know, I guess I'll put some letters down for you. And I'm going to call this thing over here. I'm going to call this dimension here. I'm going to call it, I don't know, I guess I'll call it, I don't know why, because, y is like, up and down. And I'm going to call this dimension over here x. And then I'm going to call this dimension here, this would be 5 minus x. I'm not going too fast. And this dimension over here, what would that be? That would be 8, 8 minus y. Now, a lot of people say, do I need to label the diagram? No, you don't need to do that. I just need to do that. I need to write that down. All right, so what's the area of that, shaded region? The area is the product x times y. Now, remember, this is a function of x and y. We need a function of either x or a function of y. And I'm going to try to get a relationship to get, between x and y. I don't see if I can do it. And what I'm going to do is I see similar triangles over here. So I'm going to say this triangle here, whose ratio would be, let me write this down for you, would be y over 5 minus x is similar to this triangle over here. which means it would equal the same ratio, and that would be x over, well, that whole length is 5, right? So that would be 8 over 5. So now I have a relationship between x and y, right? A relationship between x and y. I'm going to try to get rid of that fractional nature of it, multiplying both sides by the LCD. I'm getting a little better at this. So let's write this down. It's 5y equals, I'm multiplying both sides by the LCD without writing it down. That's going to be 40. Some people call this cross multiplication. Let's see, 40 minus 8x. And I'm going to keep working on it. I want to solve for y, and y would equal, I'm going to divide both sides by 5, and 5 goes into 48 times minus 8/5 of an x. And what I'm going to do now is I'm going to take this and I'm going to substitute it in up here. So what's it going to be equal to? X times the y. And what's the y? 8 minus 8/5 of an x. This here is a function of x. Right, let me write this down. So it's going to be 8x minus 8/5 x squared. And we want to do something with that. And certainly I can't remember what we'll do with it, but I do know I want to do something with this. And what does this thing represent? This is the area of the rectangle. I remember that part. What do we want to do with it? We want to maximize it. So this is a maximal problem. Now I want to point out, this could be done at the Math 100 level because this is a parabola, right? And we know the parabola's got a maximum at its vertex. But let's go through the calculus. So f prime, and what's that going to be? 8 minus 16/5 of an x. Again, the domain of this problem over here is x must be a positive number. Yeah, it must be a positive number. So what do we get over here? Let's put this down. What's a critical number? Well, it's pretty simple. We get 8 equals 16/5 of an x. So it's going to be, let's see, multiply both sides by 5/16. Let's write that down. And then you'd get x equals 5 over 2. Let me do my analysis. It starts at 0. This is 5/2. And we're analyzing the derivative. And the derivative is pretty easy. I'm looking at it. This is the derivative over here. What's a good number to choose here? 1. Good number to choose here would be 3. Let's plug in 1. What do you get? 8 minus 16/5, positive number, right? And if you're going to make 3, what do you get? Let's make an easier number, 5. Definitely get a negative. All right. So what do you know about this over here? It's a maximum. Let's go back and read the question. I'm not sure what the question was at this point. They say, find the rectangle of maximum area that's inscribed in the leg of the triangle. The sides of the rectangle are x and y. That does say that as in the figure. So I think I found it. And what I find, I'm looking at it, and I'll put the rectangle over here. They want me to find it, and I'll put this over here. That's my rectangle. What's the x? I just did it, right? And the x was what? Oh, 5/2. And what's the y? Well, I got to look at it. And the y is over here, right? And let's put that down for you. So the y would equal 8 minus 8/5 times 5/2. Well, I got to do that arithmetic. And let me write that down for you. 8 minus, I'm doing it over here now. 8 minus, let's see, that would be 2 goes 8 4 times, 20/5. And coming out at 5. We'll look at the key later. That's 20/5. Wow, not a very good diagram, right? I'm going to do a better picture over here. This is 2.5, and this is 4. So it looks more like this. 2.5, and that's 4. All right, what's the measure on this? Let me see if there's any measuring unit. Find the rectangle. No, I did it. So we got it. And what's it going to be? A 2.5 by 4. All right. All the work is over here for you too. Right. Now, this for me doing homework. I don't know if I'd look at the work unless I got stuck, and then I look at the work. I look at the answer and say, yeah, I probably did it right. Here's the deal, though. That varies from student to student. Some students need to look at the work. Some students don't need to look at the work. It's nice to have work if you get stuck, though. Let's go to the next question. That was number 3. We're going to number 4 now. Number 4, I'm going to, look at it, and I I definitely see, find the dimensions of a rectangle. I do see the rectangle, maximum area. I'm going to shade that in for you. This is the rectangle over here. All right, I see the rectangle. It's inscribed in a circle. I definitely see the circle. Circle's radius 3. So what I'm going to do is I'm going to try to, draw a coordinate system in it. Again, this varies from student to student. Not every student will do it this way. Now, you might say, I want to do it my way. You should do it your way. It isn't like doing it my way. It's doing it your way. So what do I know about this thing? I know there's a point in the circle, and I'm going to put the point of the circle. This is the x-axis, and this is the y-axis. The point in the circle is x, comma, y. So I'm going to try to figure this out, what I know about Math 100. So what do I know? I know that x squared plus y squared is equal to r squared. Well, what's r? R is 3, so that's equal 9, right? This is given to you over here. Now, what else do I want to know? I want to know the area of that rectangle. And what's the area going to be? Well, you know what? I'm going to restrict the x, y to be in the first quadrant. So I want the x and the y to be in quadrant number 1. Oh, it's over here. So in quadrant 1, that's where I want it to be. So the x has got to be greater than 0 and less than 3. And the y also has to be less than 3 and greater than 0. Right? It's going to make it easier for me to do the problem. So now I'm going to write the area of the rectangle down, the area of the rectangle. And what's it going to be? No, we're not trying to confuse you, right? What's it going to be? Well, I'm looking at it and I need to get this dimension here, and that's clearly 2y. It's twice the y. And then I need to get this dimension over here, and that's going to be twice the x. Let me write that down. So what's the area going to be? The area of the rectangle is going to be 4xy. Now, what do they want to do? I'll read it. They want to maximize this thing, but I can't maximize with 2 letters. So what I'm going to do over here, I got to figure this thing out. I got to get a function of 1 variable. So I'm going to take this thing here and I'll solve for y. And what do you get? Y squared is equal to 9 minus x squared. Now, if I'm sticking with this, y is not going to be plus or minus. It's going to be the root of 9 minus x squared. So let's write that down. So I get 4x, the root of 9 minus x squared. So I'm going to write my function down, and my function is 4x, root of 9 minus x squared. I'm going to write a little bit differently. 4x times 9 minus x squared to the 1/2 power. All right. Now, what do I have to do? I have to maximize this thing, right? So I'm trying to maximize. Let's write that down. F prime. And what's that going to be? Well, 4, 9 minus x squared to the 1/2 power plus, well, half comes down, so it's going to be 2x. And then you're going to get 9 minus x squared to the minus 1/2 times the derivative of the inside, which is minus 2x. Oh boy, I guess I gotta do some simplifications over here. And I'm gonna factor a 4 out. I'm gonna factor a 9 minus x squared to the minus 1/2 out. And what do you get? Well, let's put this down. Let's be careful about it. You get 9 minus x squared to the first power, and then you're gonna get minus, well, I factored out 4, you get x squared, right? I factored a 4 out. And I got minus x squared. Looks good. Let's keep going. So it's going to be 4. I'll write this over 9 minus x squared on bottom, the root of it. And on top, what do you get? 9 minus 2x squared. All right. Now, what happens to a lot of students is after doing work, they forget why they've done the work. And I want to point out we're trying to maximize. And we're trying to maximize this on an interval between 0 and 3. All right. So let's take a look at it. And I'm looking at it, and this thing certainly is defined in an interval. And I'm looking about at 0. So it's going to be 0 when 9 equals 2x squared. X squared would equal 9 over 2. X would equal plus or minus 3 over root 2. But, I know it's not negative. So I'll say x equals 3 over root 2. Right. And put that down for you. 3 over root 2. I don't know, maybe somewhere over here about. All right. Now that's definitely bigger than 1, right? So I'm going to say a good test point here would be 1. And a good test point over here would be, I don't know, 2. Let's take a look at that. Let's do the 1. If I put 1 in here, what would I get? 4. Oh, maybe I made a mistake there. Let me take a look at that. Did I do okay there? 9, 3, 2. Yeah, I think I did it right. Let's put the 1 in. What do you get? We put 1 in. Let's see. 1 would give you on the bottom positive number, on top positive number. And then 2. You know what? I don't think it's 2. Let me see if I made a mistake here. I'm a little confused here. And let's see, 3 over root 2, 1 point something, 3. Oh no, I got to go bigger than 2. I'm going to go 2.9. Sorry about that. I just had to think about this. And the reason I think about it, I didn't think carefully enough. I said 2. 2 is not bigger than that number. All right, let me just put this out. 3 root 2. I said that this number was bigger than 2. And if you thought about that, this is root 2 times 2. If you square both sides, what do you get? 9. On the other side, what would you get? You get 2 times 4, which is 8. And that, wait a second. That is true. Yeah, that's true. That's true. It is. 2's over here. All right. Sorry about that. I got a little confused. Happens sometimes, but I like getting confused because that way it gives me a chance to think. And sometimes it's, thinking's dangerous sometimes because if you think too hard, you can't remember anything. Let me erase it over there. So, 3 root 2 is greater than 2. So I know 2 is on the left of it. So that's why I chose 2.9. If you plug 2.9 in, what do you get? Well, clearly it's going to be negative now. So let me write this over here. So this is giving to me a maximum. All right. With all that thinking, I forgot what the question was. Let's go back to it. Let's see what the question was. They said, find the dimensions of the rectangle of maximum area. Well, I just maximized the function, and it maximized when the x was 3 over root 2. So the x is 3 over root 2. That's what the x was. What's the y going to be? Well, that looks pretty simple. I'll put this over here. And what's the y going to be? Y will equal 9 minus 9 halves. All right, let me keep going through that with you. What do you get over there? Root of 9 halves, which is 3 over root 2. So let's get over it. So what do you get? We actually get a square now. Let's go over to that. They want the dimensions of the rectangle, though. And this is where some students get really confused. The dimensions of the rectangle are going to be the length and width of it. And I have to need to double those guys. So what are you going to be? The length of the rectangle is going to be twice the x, which would be 2 times root 3. I'm sorry, I made a mistake again. Just give me 1 second. 2 times 3 over root 2. And the width is also going to be 2 times 3 over root 2. Let me just simplify that. And that's going to be 3 root 2s. And this is going to be 3 root 2s. So what is it? It's a square of dimensions 3 root 2 by 3 root 2. All right, let's look at the K. All the work is done over there, and I do see the answer there. All right, so let's take a look. Let's go to number 5 now. And number 5, again, I have to read it. And there's many ways to do the problem, but we're trying to learn calculus. I'm not saying you want to go back to what you've done in algebra to do these problems, but they're really kind of problems you probably could do in algebra and during showing some geometry as well. So it says, find a point in the line y equals 7x. Well, I'm going to draw a picture of that. And y equals 7x looks sort of like this over here. This is my rough picture. And then they got a 0.10. I'm going to put the 0.10 here. All right. And they want to find a point in the line that's closest to it. Now, someone says, I don't know where that point is. I'm just going to arbitrarily put it here. I'm not saying that's the closest point, by the way. but I'm going to say that point is x comma y. All right, let me keep going. And I'm going to keep going on to say this is x. And what's y? It's really 7x. And what am I trying to do? I'm trying to minimize the distance because I said closest, right? This is the distance. I'm trying to minimize this. Let's write it down. Look at the distance for me. So d squared is going to equal, well, it's between those 2 points. So it's going to be x minus 1 squared plus, let's keep going. What's the y value? 7x minus 0 squared. Now, distance squared, distance would equal the root of this. Well, let's write this down. X minus 1 squared plus 7x squared. This is a function of x now. I'm going to write this over here a little differently. I'm going to simplify what's on the inside. No, you don't have to do that, but I like doing it. What's on the inside? You get x squared minus 2x plus 1 plus 7x squared. That gives me 8x squared minus 2x plus 1. Hope I didn't go too fast with that. All right, what are we doing over here? Well, I got to take its derivative now. I know it's tough. And that's going to be, 1/2. And then, looking at it, that's going to be to the minus 1/2. So I'll just write this as a root in the bottom now. And then the derivative of the top, the derivative of the inside would be 16x minus 2. I think I did it right. So, I'm looking at it and, x could be any number in the universe. Certainly looking at it, I know it's not any number in the universe. It's got to be pretty close to 1, 0, right? So looking at it, and I'm going to look at it and say, the critical numbers here. Well, you know what I need to look at? I need to look at the 8x squared minus 2x plus 1. And I got to worry about, is that ever equal to 0? Let's go through that. So I'm going to put this over here. And I'm worried about it. So x equals, let's see, opposite of the b, right? That's 2 plus or minus the root. Let's see, b squared would be 4 minus 4, a is 8, and c is 1. What do you know about this thing? It's complex. So this does need to be worried about. What needs to be worried about now, is it ever equal to 0? Is the top ever equal to 0? And it is. And when is it equal to 0? When x is equal to 1/2. All right, 1/2 times 16, I'm sorry, 1/8. What's 1/8 is 16, 2, and 2 minus 2 is 0. So now I'm going to put my line down here, my derivative line. This is f prime. And there's one place I'm looking at, which is 1/8. All right, now pick a number to the right of 0. I'm sorry, the right of 1/8, which would be like 1, plug it in. And what do you get? Positive. Take a number to the left of 1/8, like 0, plug it in, and you're going to get negative, which is indicating to me a minimum. All right, have I found what that question was? Well, the question is, what's the point? And the point on that line is going to be 1/8 for x. And then what's the y going to be? Well, 7 times that number, which is 7/8. Do mistakes happen? Yeah, what time? This is why we want you to look at the answer key. And I think I made a mistake somewhere. Yep, I made a mistake. And someone says, how do you know I made a mistake? I'm looking at my answer key and I notice a mistake. So I got to redo the problem, right? I have to redo it. And someone says, why do you have to redo it? Make sure I got everything down right. Y equals 7x. I got that down right. Oh boy. And let's see where I went wrong. Probably went wrong somewhere, right? Let's take a look at it. And I think I did okay with the picture, right? 7x, x minus 1. I need to find my error. It's a problem. I hate looking back over my work too, because sometimes I just better off just erasing and doing the work over here. But what I do know is I know I made a mistake. I know this, by the way, it could be a mistake in the answer key too. Let me erase this business over here. I'm not going to erase everything. I'm just going to carefully look through the problem and look for errors. And where did I go wrong? Oh, I think I know where I went wrong. Right over here. I see it now. Let me erase this business here. Bad news. Bad news. Bad news. All that's for naught. I made a mistake. I saw the error immediately. I'll tell you what the error was. I didn't square 7x squared. I didn't do it. Right? Let me just move this up a little bit. Erase this down. Mistakes are good because when you get to an exam, if you cleared up all your mistakes, things can get better. So let's write this down. And I'll go through it again. We'll look at the answer key again. So f of x, whoops, sorry about that. So f of x is equal to, well, I'll be more careful now. X squared minus 2x plus 1 plus 49x squared. I said 7x squared last time, which is crazy. I mean, I didn't do it. Going to put f of x down again. And that's going to be, let's see, that would be 50x squared, right? Minus 2x plus 1. And by the way, I'm not saying I can't make a mistake twice. I can. I've done it many, many times. Sometimes if I get so tired, I keep making the same mistake over and over again. It's going to be 2, the root of 50x squared minus 2x plus 1. The derivative is 100x minus 2. That's pretty simple. X can be any real number. I'm worried about the bottom again. And what am I worried about? Is it, ever equal to 0? I do worry about that. And let's put that down. X equals, this should be pretty easy. And twice the A would be 100. And what do you get on top? The opposite would be 2 plus or minus, let's see, B squared would be 4 minus 4 times A, which is 50 times C, which is 1. So what I know is complex. So this complex 0, looking at it's always going to be positive. So I don't have to worry about it. What am I worried about now is if the top ever 0, and it is. And what's the top equal to 0? Well, at 1 over 50, right? One over 50. Let's test it out. What's number below 1 over 50? Like 0, plug it in, clearly get negative into decreasing function. If you took a number after 1/50th, like 1, plugged it in, you get a positive number. So this is minimal. All right. So that's where we're looking at the closest thing. So what's our point? Let's write it down now. We found x to be 1 over 50. And we found the y to be 7 times that number, which is 7 over 50. All right. Let me point out last time my error was, I'll point out to you, when I squared this last time, I said 7x squared. It's not 7x squared. That's crazy. It's 49x squared. All right, let's look at the key. Let's see if we got that. And what I mean by that, I'm looking at my key, and my key's over here. And I got it. I'm seeing it right over here. I'm seeing the answer. All right, let's go to number 6. And number 6, find the equation of the line that goes through to 0.54. I know what that looks like, by the way. I'll point out what I mean by that. If they want to find the equation of a line looks like this over here. Y equals mx plus b, or y minus y1 equals mx minus x1. I have favorites, by the way. My favorite is this what's called point slope form. So I like this form here, and I don't like this one. I'm not saying it's wrong to like that one. I'm just saying I like this one. So what I'm going to write down, I know the equation line is going to look like this. Y minus 4 equals, I don't know m yet. I'll keep reading it though. M, and then it's going to be times x minus 5. All right, I'm going to keep reading now. So it says, find the equation of the line that goes through that point such that the triangle bounded by this line and the axes in the first, oh, this is going to be really tough for me to understand. I got to understand what they've just said. Let me write this down for you. There's a point on the line, which is 5, 4, right? So 5, 4, maybe here, right? Now they say there's a line that goes through that. I certainly know that. There's an infinite number of lines that go through that, by the way. They're all over the place. They're all over the place. Could be this, could be that. Here's what they said. It cuts off an area that's triangular in the first quadrant. So I'm going to put that down. All right, let's write this over here. All right, I got that. It's pretty easy. And this point over here is, let's write this down over here. This is the point 5, 4. Wow, what's this point over here? I don't know what it is, right? But I do know it's some X number. And I know the Y is 0. I hope you know that too. And by the way, although I don't know this point over here, I know it's some number 0, Y. All right. Now, what do I know about X? I know the X is greater than 5. Otherwise, a triangle would not be formed. And I know the Y is greater than 4. I know that much. Now, someone says, what do you need? I need to find the slope. So what I'm going to do is I'm going to start to write down what the slope is for this line. All right. So what's the slope? M. And let's take a look at that. And what's M going to be? Well, I'm going to use the points and I'll write this down for you. And oh boy, it's going to be a tough one, isn't it? So let's do the slope. Let's do the slope between these 2 points here. All right. So let's write this down. So what's it going to be? I guess I'd have to write down, let's see, 4 minus 0. And the bottom would be 5 minus X. All right. Now let's do the slope between these 2 points over here. All right. Let's see what happens. I don't know what's going to happen. Let's see what happens. Let's see if we get an answer in this one over here. So what do you get? Y minus 4. Would that be agreed? Y minus 4. And then 0 minus 5. All right. Neither one gives me M, but let me simplify a little more. So what do you get? You get 4 over 5 minus X equals, well, this would be Y minus 4 over minus 5. Hope I'm not going too fast with that, right? So this would be 4. And somebody say, oh, you're wasting time because you don't know where you're going. I'm just moving forward. That's all I'm doing. This can be 4 minus Y over 5. Right? Let's keep going. I'm going to try to solve this thing for Y. Let's put that down. So what are you going to get? 20. 5 minus X equals 4 minus Y. Right? Not going too fast. 5 times 4. Yeah, that's pretty good. Let me try to solve for Y, by the way. 20 and 5 minus X. And then I'm going to write down Y equals 4 minus 20, 5 minus X. Again, I'm going to keep moving forward. And when you move forward, you may forget where you came from. And that does happen. All right. So 5 minus X, you would get 4 times 5 minus X minus 20. I'm going to write this over here. Y equals, well, that would be what? 4 times 5 is 20. 20 minus 20 is, oh, that's good. That disappeared. So you get minus 4X over 5 minus X. I don't like that, by the way. And what do you get over here? Well, I'm going to multiply top and bottom by minus 1. You get 4X over X minus 5. By the way, I still don't know what slope is. All right, I still don't. So, you'd say, hey, you're at a dead end now. So what do I got to do? I got to go back and read it. And what do they want to do? Find the equation of line such that a triangle bounded by the minimal area. Now I know what they're talking about. They got minimal area. So let's put this over here. So this is area. They want to minimize that area. And what is that? It's a triangle, right? So what's the area of a triangle? Well, that's pretty simple. So the area of that triangle, whoops, let me go back to my pen, right? So the area of my triangle is going to be 1/2 times the base. What's the base? It's X. And what's the height? Y. Well, you know what? I'm glad I found out what Y was, because now I can get area as a function of X. It's 1/2 times X times Y. And what was Y? What was 4X over X minus 5? I'm going to simplify this. And that's going to give me X squared on top. 2 goes into 4 twice. X times X squared and X minus 5 on bottom. All right. Let me keep going. And again, it's work. We know it's work. We want you to do the work. And we want you to show work. What do you get on bottom? X minus 5 squared. Bring the bottom to the top. The root of top is going to be 2X minus the top times the root of the bottom, which is 1. Let me keep going. I'm not thinking when I'm moving forward, actually. I'll come back to thinking later. And what do you get on top? You get 2x squared minus x squared. Let's say 2x squared minus x squared is x squared. And then you get minus 10x. Let me see if I did that right. 2x squared minus x squared is x squared minus 10x. Factor it. When you get x minus 10. I want to point out the critical numbers in this problem over here are going to be, 5, and I'm not even thinking about the problem anymore, 0 and 10. But you know what? I got to think back to my problem. And I got to think about what was the domain of my original problem. And so I can't remember that. And I think if you went back this thing, I remember I said that x had to be better than 5. Let's go back over here. So my analysis has to take place on 5 and above. So this can't be, and this can't be, but this sure can be a critical number now. What am I going to do now? Take test points. And what's a good test point between 5 and 10? Maybe like 6, plug it in. What do you get? Positive on bottom, negative on top. All right. Take a number after 10, like, I don't know, 11, plug it in, you get positive. What is this indicating to me? A minimum. So where does the minimum occur? The minimum occurs when x equals 10, right? And y, let's go over this over here. Again, we're not trying to confuse you. What's the y? This is the y. And what's that going to be? Well, let's see, 40, because 10 times, x is 40, right? And then, 10 minus 5 is 5. So the y has to be 8. Now, what happens to a lot of students, they box that as the answer. This is not the answer. You don't know what the question, you think that's the answer. What's the question? Equation of the line. And I was almost there. If you remember, the equation of the line was this thing up here. What did I know? It's y minus 4 equals m x minus 5. But I don't know m. But here's the deal. You do know m. And what's m? M is right over here. And what's m going to be? Let's write this down. It's going to be 4 minus 0, which is 4. And what's x? Remember, x was 10. And what's 5 minus 10? Minus 5. That's using the action problem. If I use the y in the problem, what I get? And again, I want to point out, if you can't remember, that's why we write things down. The y was 8. So I'm using the other form of slope. This is slope over here. 8 minus 4 is 4. And let's see, minus 5. We get the same slope. All right, so let's write this down. And what's going to be? Y minus 4 equals the slope is going to be minus 4/5 x minus 5. And this is a good answer. I realize some students want to rewrite this as y equals mx plus b. Let me go through that for the students that want to do that. Y minus 4 equals minus 4/5 of an x. We'll look at the key later. Plus 4, right? So what do you have here? Y equals minus 4/5 of an x plus 8, which makes sense. We were expecting the y-intercept to be 8 anyway. So 2 answers. Let's look at the answers they provide for us, and they provide these answers over here. All right, same story. All right, so I think we did okay with that one, and I think we're doing fine. I know this is for a lot of students, a lot of work. We're encouraging the work, and I think we're at the end. I don't think there's any more questions, and that's good news as far as I'm concerned. We did them all. All right, it wasn't so bad. Thank you for your paying attention. Again, if you need help, please come by during office hours, and I'll be more than happy to help you with this material.